Hi everyone, it's Adam again. So this is, I think, the 8th video. It's been a while since my last one. Going over Leaving Maths Paper 1. So today we're going to go through discriminants and other things, but the first thing we're going to do is a discriminant. So first of all, I'll write down the minus b formula. So minus b plus or minus the square root, all divided by 2a. So the discriminant is always this thing here, okay? So basically what they want to know is, okay, when is b squared minus 4ac, when is this less than 0, when is it equal to 0, and when is it greater than 0? Okay, so that's what they're asking. And the reason they want to know this is because, again, there's 3 scenarios, so let's do it. So if we have, if it's less than 0, what happens is you have your graph like this, and your quadratic will look something like this, or it can look like this. Basically, when this thing is less than 0, so I'll just put it in green. When this thing is less than 0, you basically, it doesn't cross the x-axis. Okay, where that's x and that's y. Now, if it's equal to 0, then what happens is, where that's x and that's y again, what happens is that it'll come down and it'll just touch the axis and go away. Could also happen like this. So it'll just touch the axis. Okay, I didn't really do that great, but you know. So it just touches it and then goes away. And then lastly then is the one that you're probably most familiar with, is if this is greater than 0, then what you have is, you have 2 real roots. So again, a root of a quadratic and really any equation, but just specifically, is when you have ax squared plus bx plus c equals 0. And then this solution is the minus b formula. Okay? So that's why this thing here is very important. Because basically, if that's greater than 0, then you can take the square roots. Let's say it's equal to 4. You can take the square root of 4, get 2, and then just do things like normal. If it's equal to 0, then what happens is, so say if your b squared minus 4ac is equal to 0, this means that x equals minus b plus or minus the square root of 0 over 2a, and that means that x is equal to minus b over 2a. Okay? And another thing to highlight is that this for quadratics, this is the minimum / maximum x value for the quadratic. So if you look here for this graph here, that would be your minus b over 2a. Okay, so it's either your minimum, or in this case up here, it would be your maximum. Okay, so that's another thing to know about the minus b formula. Okay, also another thing is that the quadratics are always symmetric. Okay, that's another thing to, so yeah, just to note that quadratics are symmetric, and they're symmetric about the minus b over 2a point. So if you cut a line down at minus b over 2a and fold the quadratic over, it would fold over on top of itself perfectly. Okay, so some of the questions that you can get are something like, Now you can get proving ones, but it could just basically be, you know, something as simple as what's the discriminant of x squared plus a minus 1 minus 9 equals 0. And basically what they're asking is they want to know, okay, first of all, what's the discriminant, and then what values of a can it take on to give you 2 roots, you know, 1 double root, or no roots. So if I do b squared ac, what I get is I get a minus 1. So remember, b is the, sorry, there should be an x there. Sorry, that's my fault. Okay. So what, again, remember what this is asking is, it's saying, okay, b is how many x's you have, a is how many x squared you have, and then c is just the constant at the end. So I get minus 4 times how many x squares do I have? 1. And what's the number at the end? Minus 9. So this thing is equal to a minus 1 to b squared plus, this is going to be minus by minus is plus, and then 4 by 9 is 36. And this is always greater than 0 no matter what. The reason it's always greater than 0 is because this is something squared, so that's always greater than 0, and then this is plus 36, and that's also greater than 0. And therefore, if I add the two of them together, I'll get something that's greater than 0. Okay. So it just could be something like that. Another thing that I could do... Okay, so another question here. It says, show that 4ax squared minus 4ax plus a plus c squared equals 0 has no real roots. So again, if I do the discriminant, so b squared minus 4ac, this equals, so how many x's do we have? We have minus 4a squared minus 4 times 4a multiplied by a plus c squared. Okay. So I'm just going to multiply this out and see what I get. So this gives me 16a squared minus, that's going to be 16a multiplied by a plus c squared. So I get 16a squared minus 16a squared minus 16ac squared. Okay. And so now this is equal to minus 16ac squared. Okay. So I know the question said to show there's no real roots, and that's because a is positive. But if you were asked, again, your 3 scenarios. So when is there no roots? When is there 1 double root? And when is there 2 real roots? So when is there no roots? When a, so again, this is equal to minus, sorry, wrong pen, multiplied by a. So again, this thing is specifically less than 0. This, so a now, so if I want no roots, I want it to be less than 0, and therefore I want a to be greater than 0, because something positive multiplied by something negative is something negative. So if I want no roots, then I want a to be greater than 0. If I want 1 double root, I want this thing to equal 0. So if I want minus 16 a c squared to equal 0, I can just let a equal 0. And then if I want 2 double roots, I want this thing here, I want that to be positive. A negative multiplied by a negative is positive, and therefore I want a to be less than 0. Okay? So hopefully that makes sense. And now on to inequalities. This is the last part of this chapter, which I think is can get quite difficult. Yeah. So here I'll do like maybe 3 of them. I'll do 1 easy, one medium, and 1 hard. Okay. So yes, what you have is that you might be asked to prove that p squared plus 1 is greater than or equal to 2p for p in the reals. So basically what that means prove that this is true no matter what. So always what you want to do in these, you want to show that something is greater than 0. Okay? So I can say this is equal to p squared minus 2p plus 1 is greater than or equal to 0. And this is equal to p minus 1 to p squared, which is indeed greater than 0. So you always want to change it in such a way that you can show that it's basically greater than 0, you know? That's all. Okay. Another one. I want to show that for p and q greater than 0, that p plus q is greater or equal to 2 root pq. Now this might look really weird, but it's quite literally, it is the exact same thing. This means that p minus 2 root pq plus q is greater or equal to 0, and this is equal to root p minus root q squared, which is indeed greater than or equal to 0. Okay, so yeah, that's all it is. Okay, now I'll do this. This is quite a hard one. And honestly, I remember doing it when I was younger, and I'm not sure if I'll be able to do it now, but yeah, we'll see. Because I just remember that I couldn't do it. Alright, so first part is prove that x squared plus y squared is greater than or equal to 2xy. Okay? Yeah, and that is again just x minus y to be squared is greater than or equal to 0. So just the exact same thing that we just did. Just bring it over and then just factorize and off you go. The exact same thing with this one. It says show that x to the 4 plus y to the 4 is greater than or equal to 2x squared y squared. Again, this is x squared minus y squared is greater than or equal to 0. Okay? Now, this is the really hard one. I need to show that x to the 4 plus y to the 4 plus z to the 4 plus w to the 4 is greater than or equal to 4x, y, z, w. Okay. Okay, I'm taking a bit of a risk doing this, but because I'm not actually sure if I can show this or not. Okay, yeah, no, never mind. Okay. Yeah. So basically what I want to do is it's using this, show this. So I know that x to the 4 plus y to the 4 is greater than or equal to 2x squared y squared. And that means that z to the 4 plus w to the 4 has to be equal to, has to be greater than or equal to this. Okay? So, I know that x to the 4, y to the, plus y to the 4, plus z to the 4, w to the 4 is greater than or equal to 2x squared y squared plus 2w squared z squared. Okay? So now what I want to do is I want to show that this is greater than or equal to 4x, y, z, w. So the thing is, I know this is true. So I know that this is definitely true. So if this is definitely true, then if I can show this, then I proved it. Okay? The reason is because if I can prove that this thing is bigger than this thing, and then I can prove, so this I know. This is the thing that I don't know. But if I can prove that the left-hand side is bigger than the middle, and the middle is bigger than the right-hand side, then the left-hand side has to be bigger than the right-hand side. So that's the thing now that I want to show. And this is actually just, this is simply, I can divide by 2 and get x squared, y squared, minus 2x, y, z, w, plus w squared, z squared is greater than or equal to 0. And this gives me xy minus wz squared is greater than or equal to 0. So yeah, that's that proved. Okay. So yeah, so basically this is what this kind of comes down to, is that if I want to show that A is greater than C, and I know A is greater than B, then if I can show that B is greater than C, this implies that A is also greater than C. So that's all I use there. Okay. So yeah, that's the end of Algebra 3. Took me an extra video to do. So I'll finish up now, and the next one will be going on to kind of financial maths. Okay, perfect. Thanks very much for listening, and I'll see you in the next video.